Okay, hi. Welcome to homewreckery, electrifying the thread out of clothing. Am I too loud? No? Okay. As a quick note, I haven't slept in 2 days and I have a sore throat, so pardon me. And before I start properly, I want to thank a couple people, so bear with me. Firstly, thank you to Jeff Kinterick, Jordan Bunker, Joshua Kruger, and John Stoner. These four folks have been absolutely indispensable to everything I've done here. They're my greatest collaborators. 3 of them helped me make sure that I didn't have a huge mental meltdown in trying to make my electronics work, and 2 of them let me talk about their projects and their processes and their obstacles and everything else. So you will get to see their projects later on, and onward. Here's a quick intro so you know what you're getting into. Again, hi, I'm Eli Skip. I'm a member of Chicago's Hackerspace, which is again Pumping Station 1, and it's thanks to all the endlessly intelligent people there that I got started with any of this at all. Aside from that, I'm an art design writing student. There's the logo of my fine and esteemed institute. And I've been sewing garments for about 8 years now. That's my octopus hat. And that's the jacket I'm wearing now, which I'll talk about later as well. And I've been doing embroidery for about 4 years. That's my zombie jacket. And I'm wearing those jeans too, which is a good coincidence. This isn't going to be a terribly advanced talk, so pardon. I'm a little bit of an old hat at sewing and embroidery, but I'm really new to shoving my crafts full of electricity, so very basic stuff, but also really cool. I'm going to cover really easy and awesome projects. These are 2 of mine, one in progress, the other one not. And for the most part, they are all really endlessly applicable. You'll get an idea of how to build them yourself, which will be great. And I'm going to begin by going over some components you should probably have around if you're going to make anything like this. They're very important parts. And then I'm going to go over 6 different projects now, so yeah. Okay, onward to serious business. Firstly, I just want to say that this fabric hacking, that sort of thing, is really new. It's until a generation of people like us, which I guess isn't that new of a generation anymore, if this has been going on for 26 years. It's until people like us that this happened. Before that, clothing was really, really static. Fabrics changed. We put plastic in what used to be organic. Our pants got really baggy and then got really tight again. We figured out how to make everything stretch without cutting on the bias, which has saved us a lot of resources. But for the most part, they really kind of only exist to save us from the elements and cover up our nakedness. But now they can really serve any manner of purpose. There are endless things you can do with them. You can gauge your breathing during your yoga practice like this lady did. That's a circuit board that I wish I could have. She ordered it, but designed it. And as she breathes, the lights get brighter and darker and brighter and darker, so she knows how she's breathing when she's doing her yoga practices. You can play Pong on your partner's stomach. I love this picture because it reminds me a lot of high school. It's like saying to your partner, no, don't worry, all we were going to do was rock back and forth awkwardly and not look in each other's eyes anyway. So I think that's very cool. That's actually just a couple of accelerometers on someone's back, lily pad accelerometers. Very awesome. Or you can force yourself to smile if that's your gig. This hat has a sensor which touches your cheek, and if you're not smiling, it stabs you in the back of the head. Anyway, more to the point, you can build all of these things yourself, except for the circuit board. She ordered that, but she still designed it. So for the most part, all of this kind of easy to do. All you need is a little instruction and the right components. So here are the seriously important parts that you should probably have around. The first is conductive thread. I actually have used this a lot and don't like it that much, but you can't really do without it. So sorry, guys. You can get it from a whole lot of places. There's sparkfun.com, there's fungizmo.com, there's plugandwear.com, which has some awesome stuff. And it comes in 2 different thicknesses. There's 117 by 17 ply, which is about the thickness of regular thread. And then there's 234/34 ply, which is like embroidery thread. It's a bit thicker. No! His name's Russo. I quit that. Okay. Serious business. We're onward to serious business, I promise. Okay, will this bring me back where I was? No, it won't. Okay. Okay. Anyway, again, comes in embroidery thread thickness, that's 234/34 ply. It's made from braided filaments of various fibers, so a lot of different alloys, but silver, copper, tin, anything that's conductive, and it's also cotton and polyester thread, and it's generally uninsulated, but don't worry, it's not going to shock you. And it should be noted that there's about 1 ohm of resistance per inch. It is crazy high resistance. It's terrible. It really is. The 117/17 ply has far more resistance than the embroidery thread one, so try to use it when you can. It's good stuff. And the resistance also changes when you stretch it. I can't remember if it goes higher, but it probably does, knowing this stuff. It's very finicky, but it's also very cool. But if you'd like to make your own, which might well be more reliable than the kind you can purchase, this is an instructable site on how to do it. As a note, if any of you want these addresses and don't have time to write them down, at the end I will give everyone my email, my Twitter, and a link to a slideshare.net profile where you can get them all, and a copy of this presentation. Thanks, aesthetics. Okay. Second thing, and I love this stuff, I think it's magical. This is conductive fabric. I get mine from lessymf.com. They ship internationally, they're great. You can also get it from plugandwear.com, I recently found out. They have a huge selection of this stuff. It comes in mesh, it comes made out of silver, it comes made out of copper, it comes made out of nickel. It comes in stuff you can solder to, it comes in stuff you can't solder to. Some of it's stretchy, some of it's not. Fun fact, this stuff is actually made primarily for shielding, not for what I use it for. So if you want to cover your cell phone in it, you'll lose signal. Or if you want to hide all of your luggage in it, they won't be able to x-ray through your bag and see your luggage. That might be a really bad idea considering the climate now, though. My favorite type, and I recommend this one to everyone, is the copper polyester taffeta. It's a lot like regular taffeta, but made out of copper. It's extremely cheap by comparison, especially considering how wide the bolt is. It's about this big wide, and about $10 per foot, and this is again shipped internationally. My favorite part about it is that you can solder to it without damaging the fabric whatsoever, and the resistance on there, and this is why I say it's magical, is magically low. There is less than 0.05 ohms of resistance per square inch. It basically has no resistance. It's fantastic. Again, Instructables has a great tutorial for this. It actually really just involves getting conductive glue and spatulaing it across any piece of fabric, but I guess that works. So there you go. That one's going to be hard to write down, though. LEDs, actually not necessary at all, but really glowy and pretty. So I put them up there, and also people use them in everything, myself included, so why not? But yeah, really easy to use, really pretty. Conductive glue. Conductive glue is useful for just about everything, but it's especially a lifesaver if you've got stubborn thread like your embroidery thread starts fraying, which will happen to you if you use it every single time, and you'll spend hours worrying about whether or not your wires are crossed because it'll fray into each other. But yeah, so good for unraveling thread, good for finishing off circuits. But you can use it to make your own conductive thread by painting over the thread, again to make your own fabric by spatulating it onto the fabric. You can make pretty much anything conductive with it, although you might want to use conductive paint in that case. Still, anywho, it's really just made of powdered conductive metal and some sort of binder or glue mixed together. So very simple. Instructables, who once again have a tutorial, recommend putting carbon graphite powder, which you can get in massive quantities, like vats of it from art stores, and liquid tape together, and you can have your own conductive glue, which is probably better than the stuff I have, which is very watery. Next thing, lily pads and associated components. I also hate these things, but they have to be mentioned, really. I mean, you can't get through a talk like this and not have them be mentioned. They are adorable, to say the least. They're all really brilliantly designed. I just don't like them because conductive thread makes them difficult to work with. Wait, I can show you how difficult it was. This is a project I made. It's actually this jacket. I ended up taking this out. I made a huge mess. I couldn't get the thread to stick, so it's now covered in crazy glue and probably doesn't work. Anyway, these were invented by Leah Buckley, specifically for conductive threads and soft circuits. It's ringed by these wee little holes, and they're conductive all the way through. You can still solder to them, but I really wouldn't recommend it. And the great thing is that you just program it with your regular Arduino software, because all it is a really adorable little Arduino that you can sew into things. Yes, there's some great associated components. My favorite is this tiny switch. It is so small. I love it. And the sewable battery packs are great too, but there's also accelerometers, vibration pads, kind of anything you'd need comes in sewable form now, which is brilliant. This thing is not a tutorial on how to make your own, I'm sorry. It's a component circuit layout tool. It will only cover your LilyPad components though, so if you want to put in LEDs or a battery pack or anything, you can't do it, but you can lay out your LilyPad components, which is pretty cool. Okay, I made two projects specifically to show you fine folks. I'm wearing one of them and have one of them here, but I also have slides. Whoo! And they're really fun to build, so this is the part of the talk where I talk about the stuff I made. Here we go. This is the first project I finished. I finished this about a month ago. It's been on Hackaday and Make and a bunch of other places, which was a huge honor. I was very excited, especially considering how extremely basic this is. I call it a fabric light bright, but I will seriously build one and send one to anyone who can come up with a wittier name than me. I mean it. Okay. Yeah, I'm desperate for one. In a way, it's a lot like a fabric breadboard, but there's definitely limitations regarding that. So if you really want a fabric breadboard, again, pluginware.com has one. I'm not advertising for them. I just found out about this. They only started stocking it about 2 days ago, so now you know. This is how I actually wanted to build it the first time around. I guess I'll get into the sewing part in a second, but this is a Husqvarna Viking embroidery machine. It costs about $2,300, and you can literally take a USB key of any image you want, plug it in there, and it will embroider it for you in the colors you want. It's amazing. And so our idea, and we've started working a little bit with a Husqvarna company, but barely, so pardon my lack of pictures, is to start making printed circuit boards using conductive thread and the Husqvarna machine. I share this idea with you because if any of you have access to this kind of machine, please, for the love of God, make me a printed circuit board out of conductive thread and show me. I will love you forever. Okay, anywho, I made it in the first place so that I wouldn't have to do wiring for every little LED image or word I wanted to do. Individually addressing LEDs is a problem for me. If you're more ambitious than me, you can hook up other stuff to this. I've just been using LEDs. It was a way to get away from the staticness and permanence of other soft circuits that happen. So anyway, again, luckily, so criminally easy, you could make it in about an hour. Mine took a long time because I was stupid and hand embroidered it. Don't make my mistake. The only possible advantage to hand embroidering is that you could make pretty conductive pictures or something, like leaves or birds or whatever. You pick. Otherwise, use the sewing machine. You'd save yourself like days of tedious work. Takes forever. I'm going to give you a basic idea of how to make it. I'll try to be quick about it so we can get on to the other stuff. But to build it, first you need to sew a continuous line up and down, like that. Okay, use the zigzag stitch. It's wide, it's fancy. You want to make it about 1/4 inch to 1/2 inch apart, which is about 0.65 centimeters to 1.25 centimeters for all you metric folks. You'll notice that your thread, your needle will not fit your thread, and your spool will be too massively gigantic to fit on your sewing machine. It's a bit of an issue. So this is what you do to get around that. This is the only way to use a sewing machine. Well, it's not. You might have a sewing machine that fits it for some strange reason. But really, this is the only way to use a sewing machine with conductive thread. It's called bobbin work. It is essentially sewing upside down. You want to thread your bobbin with your thick conductive thread, stick it in there, and sew normally. done and done. It's great. It works for ribbon, kind of anything. It's fantastic. Love it. Anyway, that URL will send you where to go. We've got the pretty little diagram. Yep. Okay, once you've got your lines sewn, kind of in the similar fashion of mine, but probably far neater, you want to get a couple strips of conductive fabric, sew them over the top and the bottom. You get minimal resistance that way, voltage is all spread out. Then you want to sandwich a piece of conductive fabric that is the same size as your first part, and then one that's regular fabric in between, and sew those together. And it should be noted now, I suppose, yeah, that the bottom part, the conductive fabric, is working as your ground, and the conductive thread is working as your positive, in case you didn't notice. This is actually a lot of fun. Yeah, make sure they never touch or you'll short your circuit. That's not a good thing. Grab 3 AA batteries and 3 AA battery pack. You want longish leads. And then you're just going to take one of the leads and you're going to poke it in between your conductive thread and bend it around. That's your positive lead. Done. You're going to do the same thing for your ground fabric with your ground lead. Done. This is a very impermanent way of powering it, but you can make it permanent, which I'll talk about. At this point, you're going to stick some LEDs through it. This is my funny little diagram for how to do that. I curl one end of my LED, which is actually taken from Leah Buckley's idea for that. And then I sharpen the other one with snippers so it'll go through faster. And go ahead and test it. Does it work? Huzzah! Wonderful. This is actually a picture from when I realized that mine would work, and I went crazy and screamed at everyone in my hackerspace. Once you're done with that, you're welcome to go ahead and solder your ground lead to the back. Let me see. Yeah, if this has been really vague, I have a PDF up on Pumping Station 1. Again, this will be linked to SlideShare so you can find it. But I make this really kind of fun by usually strapping these to bags or jackets. That way you can have blinky bags and jackets. And I have a little switch on mine, so my hookup is permanent because I have one of those really adorable tiny lily pad switches. Love them. Okay, second project was a pain in my butt. I can't say curse words, can I? But pain in my butt for weeks. Nope. Okay, this is the jacket I'm wearing that's up here. It was made out of my old jacket, and it took a while. I actually hand embroidered PS1's old logo in the back and on the side, like right here, which took me a very long time. And I settled down thinking that that was plenty of work. Turns out it's not, my friends say to me. Eli, you should put some LEDs in it. Fantastic idea, I'll do that. Eli, you should attach a lily pad to your jacket and make your LEDs change patterns. Fantastic, I'll do that. Eli, you should put flex resistors into your jacket so that that will control the pattern changes that your lily pad is controlling. And thus did it get epically complicated. I made a mistake. I decided I wanted a lot of LEDs. Don't do this. I curled 96 LEDs. I made both sides exactly the same so I couldn't figure out what was positive and what was ground. I actually have a whole bunch of those with me if anyone wants one of my failed LEDs, but I was really freaked out. I thought I was going to have to multimeter them all individually, but no, my friend Jordan made me this nifty thing. Very useful. All it is some coin cells, a couple sensors, and a positive and negative telling me what side is which so I can sew it down. Problem solved? No, problem not solved. I started attaching conductive thread to the ground side only and then realized that this would be a very, very complicated circuit. Circuit plus that image equals does not work. Does not work. I used 3 layers of fabric to complete it originally, going off the basic idea of this, so ground sewn down, regular fabric, layer of conductive thread attached to my positives. That didn't work very well. There were probably still lines crossing. I checked it with a multimeter, and then I tried to program it, and then I gave it a whole bunch of juice, and it all failed to make more than one LED light up. I did it twice, and I tore it apart each and every time. That's carnage right there. That's a month of work. It was very sad for me. I did it twice, gold darn it, and I was devastated. Luckily for me, though, the same guy who made me my nifty thing, Jordan, he took pity on me and sat down with me and said, Eli, I think we should probably make this a little simpler and a little more analog. And I went, okay, that sounds great. And he drew me a little circuit pattern out. Can you tell that I don't own a real camera? But he drew me this. You can see where my positives and my negatives go. They're all color-coded. Yeah, I needed that. And then Jeff made me this adorable little circuit board. It's like 4 resistors, 2 capacitors, and a whole bunch of solder on a tiny perf board. And then I sewed it all up. There's my 234 by 34 ply, because that gets very low resistance. I actually did this with 117/17 ply originally, and it didn't work. That's why I hate conductive thread. Conductivity was terrible, ripped it out, put this in, and then just kind of literally swabbed the entire thing with fray lock so that it wouldn't come apart and cross. And then I think all of my LEDs might be kind of black now because they're completely covered in glue, conductive glue. But boom, it works. I was really happy. I screamed at my whole hackerspace again. I think our vice president was really creeped out. And I'm going to show you a video of, we put the flex sensors in. It turned out they were a little bit trickier. So this is my friend Jeff. Jeff made me this thing. Nope.
About 3 volts. And here's the flex resistor.
I know it's hard to hear.
All the way over, and hey look, there the LED lights up. And it's even a little bit variable too. Pretty cool.
He's right. Anyway, he was showing me that it took 3 volts, in case you couldn't hear that part. The beauty of these things, which is what that's trying to show you, is that as you flex them, the resistance changes. Flex them one way, it goes down. Flex them the other, it goes up. So you can use that to tell, through a circuit, to tell your lights to light up. This is the circuit he made. I don't know what any of that means. But he tells me it works, and I believe him. So again, that's the little circuit board I showed you beforehand. And then after that, I started sewing the flex sensors. I sewed them into the crooks of both arms and attached some really, really long wires to them. And then I sewed fabric over them because, interesting fact, flex sensors are shorted out by human skin. Anyway, those got sewn down and assigned to their respective places on the circuit board, and that was put into my little pouch that I have right here, along with my batteries. There's 2 AA's powering it, and one of the flex sensors turned out to be defective. This jacket was the devil. So Jeff replaced that one with a with a regular resistor. That's in here, there, and then this one's still here, and we finagled it together to make sure that this one works, and this is a little bit less sensitive. So I can show you me wearing it, but I can also show you this video of me dancing around being really happy.
Yeah.
Awesome. Oh, and there Nate comes out of our TARDIS with a jigsaw, and I ran. Does it work if I do this now? Bam!
Yeah.
Bam! Yes! Oh, I was really excited. Thank you. Wait. I can do it for you too, but very briefly, because again, the conductive thread is really finicky, and so most of these probably won't light up like they're supposed to. So wait. Nikki, tell me if it's working. Boom. Yay! The fun part was that I got to premiere this at a huge dance party. So, lots of good stuff. Okay, other stuff besides my own. This is the good stuff, guys. Here's Jeff Kantarek again. He's Speed Racer. He was a professional electrical engineer until he became extremely happily unemployed. Now he mostly just builds things with a startup company and helps everyone around the space, yours truly included, figure out what they're doing wrong with their projects. He is creating a biofeedback shirt. You can see all of his components. They're kind of messy. It's still currently in progress, but I'd like to update you on how it's going so far because I think it's very, very cool. The premise of the project is that it provides biofeedback in order to improve balance for people who have inner ear problems, perhaps any kind of balance-related issues. It uses a lily pad, an accelerometer, a bunch of vibration pads, and a LiPo battery, plus a bunch of conductive thread, lots of conductive thread. Here's where he made a huge mistake. Jeff does not know how to sew. He decided that before he sewed it down, or rather had his mother sew it down for him, he was just going to make all the connections. It quickly got extremely tangled. I don't even know what he's doing there. I think he has his vibration pads literally completely wrapped in conductive thread and scotch taped together. It was great. So it was a ton of messes and tangles and frustration. And then he realized that was a bad idea and learned how to sew. He originally used the same embroidery thread that I used for my light bright because it has better resistance, but he had to switch to the 117/17 because it's pretty much the only one that will actually properly knot through the lily pad. Otherwise, it'll just come apart, which is why I used crazy glue. Yeah, but he drew up a new shirt and sewed the thread properly in and not as messy, and then sewed fabric over it to allow for overlap so that he wouldn't have the crossed wires that you get. The ground connections were completed, an accelerometer was attached to the analog inputs on the main lily pad, as you can see, like right about there. And he put a little pocket in. Can you see the pocket? No? Okay, well, there's a tiny black pocket down in that corner, I promise you. It's like right there, right there. Okay, that's where his battery is. And then the vibration pads were attached and sewn to positive leads. These are his little vibration pads. Look how cute they are. I love those components. Those go on the inside of the shirt around your waist, directly attached to your skin. And when your balance goes off center, they vibrate and let you know. This is actually his prototype, so I guess he's moving to talk to other people about it. But unfortunately, he realized that the shirt was a terrible idea and that a waist belt was a much better one because he didn't have to use conductive thread to do this. This is all, pardon me, regular and analog, and this was his second prototype. And his third will include stretchy conductive fabric because he also realized that it's magically not resistant. Anyway, what was I gonna say? Yeah, you can check out his site. That's Effective Engineering. He's got a lot of great projects there, including one that I wanted to show and was unable to because it was never finished, called Warm Strings. Our friend Yasna made it. It is a knit scarf, lily pad, some speakers, and when you touch it, it plays violin. It's very cool. But that's not done, and she avoided me because it wasn't. This is Horace. I love Horace. I have Horace here. Anyone who wants to afterwards can come play with him. Let me tell you, TSA didn't want to let me through with him. He looks like a bomb. Or so the English tell me. I made this stuffed animal. I made 16 of them for a class, and then he took one of my extra ones and attached a battery pack, some acrylic, a couple of these little cell phone vibrator stick things, which are what make his wings, and then he made this huge ball of LEDs and like hot glue. It was like this, and I stuffed it into the belly. Let me make these things work, though. Sometimes they don't go. Oh, yay! Oh, it's spinning. Look at them. They spin. Oh, and he lights up. Nobody can see this, I'm sure, but his buttons light up too. It's very adorable. I don't actually know how that one works. He never told me. He just said I had to bring it with me. So I did. Now I'm going to talk about a project by John Stoner. John Stoner is a great member of our hackerspace. He is also an incorrigible member of the cycling community in Chicago. He bike rides everywhere, including through our extremely harsh and desperately dreadful winter. And he's also a really good programmer. He made this thing called boogie pants, which is really hard to see, I know, but a belly dancer he's working with to do this stole it and wouldn't give it back. So that's the only picture I have. That's from our Geek Prom Science Fair in Chicago. This actually doesn't have any of the components I talked about before. I apologize. It's a little bit different from the rest of the projects, but I think it caters more to the programmers amongst you. It's less an example of electrifying clothing and more an example of how awesome relationships that technology and fibers can have together. It incorporates, again, none of my indispensable components, but I could if you really wanted to get fancy, but it deserves mentioning. It was made using an apron-like garment, which I showed you before, and a Wiimote and a nunchuck, not to mention a pretty good knowledge of Java and Wiimote hacking, none of which I can explain. But John can. This will again be online. This is a link to his site where he has everything completely open source, so that's all of the programming and the back end of it, which is done using pure data, which you'll see in a bit. So what does Boogie Pants do? I shall tell you. John says to think of it like a synthesizer keyboard. Different media events are assigned to different controls on the Wiimote and the nunchuck, for example, a sample of tone. And best thing ever, it's controlled by dancing. That's why he's working with belly dancers right now and why they won't return the garment. It's still a work in process, so, but he's working with them to show how, wait, no, did it go backwards again? Yeah. There we go. Sharp movements will make sharp sounds. Oh, that doesn't sound so nice. You got it? Wait, because I'm going to show you how that back and forth movements can make scales. Oh, this might take a second. Does it? Oh, that sounds awful. By all means, when he's done with it, it won't sound this terrible, I promise. This is what he's got so far. He's working with a lot of people, and this is my last one, so earmuffs, guys. It's a lot of fun to watch this stuff working. Okay, I'll stop that. Okay, but he's working, thank you. Are you clapping because I made you hate your ears? Or because my friend's project is cool? Okay, yay! I like that one. We'll go with that. I'm gonna tell you guys what John told me about it, because his words are great. He wanted me to tell you that it's a brand new category of thing to use video game technology and fibers together. And then he said to imagine a belly dancer on stage. She's got the garment on. It integrates wireless motion sensors, and there's an image, an avatar, a proper one, not rectangles, proper one, projected on the screen behind her. And as she dances, the avatar is going to move with her body, and it will interact with different objects on screen. So the idea is the media events will go according to the Wiimote, and various different things will happen. You can control a whole bunch of different things with it, not just sound, images, whatever. And as she pushes buttons, sets of objects will swap out. It's a fully open source project, by the way. The code is open source, and the garment designs will be too. He says he welcomes collaborators, so if you'd like to, feel free. He says that coders, dancers, DJs, 3D modelers, all of them have a place in Boogie Pants. He wanted me to make a note that all Boogie Pants instruments require an OSC address, which defines where their signals go when they are played. Different instrument types send different signals. All Boogie Pants signals are single floating point numbers. I don't know what that means either. I like how you guys like when I admit that I'm incompetent. Okay, for the future, he wants to change a couple things, which I like what he's thinking about. Right now, it's based only on the tilt sensing. So it only works with the core of the body and with the pelvis, but he wants it to be full motion sensors and more of them, controlling more music, controlling everything. So your arms, your hands, your legs, all different parts of your body. And then he said to imagine going to see a Daft Punk concert, something like that, and all the people, instead of sitting behind a DJ booth where they're kind of a little bit boring, they get out from behind that DJ booth and they dance, and their dancing makes their music happen. That sounds like a lot more fun to me, at least. And he says it would be a lot more fun if you're going to the Super Bowl, Jumbotrons. You know what I'm saying. I'm not going to keep reading this. Anyway, he also wants there to be easier programming and extensibility of visual effects. So right now there are only 4 different types of controls in Boogie Pants. There's 4 instruments, and they're pretty cool, but they have pretty limited visual appeal and dynamicism, as you can see from what I played, what made the loud noises. And he said that eventually it will be easier to add visual effects to what you're doing and musical events to what you're doing, so you have that power directly as an artist to change what your avatar is doing, what music it's playing. And you can find that at boogiepants.typepad.com. Yay! Okay, and this next one is very last minute. Hi, Alex. I tried to get Alex to talk to me about his tactical corsets for 2 months, and he never did. But I'm wearing one now, and I have some slides about it, which he gave me, so there you go. There is your ad copy, which apparently is obsolete. And again, I don't have it with me as obsolete. The great thing about this is you can literally attach anything. I don't even know what's attached to me right now. If any of you feel like giving me your keys, I'll put them on. No? Oh well. I don't even know what this one's about. Yeah? Hey, that's Christina! Sorry. Anyway, he wanted me to put that up. I'm actually really excited about this, though. He's putting project boards and perf boards and breadboards behind this, so you can actually power your cell phone, your computer, all these funny little things just by sticking them under these straps that I got right here, what would normally be holding all your keys. Yeah, and I guess he's also putting a heart sensor in there, which he decided not to finish in time either. Anyway, I'm really excited about this because I really want one of these things. Definitely. And he tells me, and I guess this is a big announcement, I don't know, how many people have you told? Oh, yes! Way excited. Okay. Should I tell them? Yeah. They're going to be for sale starting on the 1st. I can't be the only one who really wants one. Look. I'm very excited about that. Okay, even if you're a guy who's not going to run around in a woman's corset, you can at least appreciate all the women that will be running around in them. Maybe? Okay. Anyway, how long have I been talking? No? Yeah? Really? Sweet, because I'm done. Wait. Okay, I said I was done, but I have some really quick things to say, and then I'm done. Okay, so that wraps it up for pretty much everything. I guess in conclusion, awesome things happen when you put clothing and electronics together. I quite like them, you know, even if you just want to make them blinky and shiny. Pretty cool. Most of these creations come with problems to start with, but you work through it, becomes great. My fashion teacher used to tell me that there will always be a market for clothing like this because everyone loves clothes. I don't know if that means anything to everyone, but so why not have them be more interesting? Anyway, here's my email and my Twitter and the slide share where this will be up, and it will include all the web addresses. If you want to email me with anything, you can totally email me suggestions and criticism. This is the first talk I've ever done at a conference and the first conference I've ever been to. So be nice, please. Anyway, cheers, and I guess I'll take questions now. That's what we do, right? Okay.
Line up behind the microphone stands, and I will take your questions.
Yay. Thank you. And just to make you be nice, I'm going to put up this picture of me being sad for the rest of the questions. Hi, Jimmy. I haven't seen you in an entire year.
It has been a while.
Yeah.
So I'm Jimmy Rogers. I actually do some wearable computing as well, and I know a number of people who do stuff. I've seen Leah's stuff, and she uses the thinner electronic thread.
She does.
And gobs of the glue,
Yep.
the conductive glue. Everything is glued into place. It frays something terrible. It's horrific stuff.
It does.
So Fabienne actually gave me a suggestion where she uses 30 gauge unshielded wire, which is really thin solid core wire, and you can sew with it.
Really?
Yes.
That's exciting. Thank you for
So
telling me.
You can sew with that, and then you can solder it into place. Yeah, it's really nice.
Thank you for telling me. I'll
Yeah.
put that up here.
There was something else I was going to say.
I like
Yeah.
how you have it written down. I appreciate
I only
that.
wrote one of the two things, and I forgot the other one, so that was it.
That's cool. I appreciate it.
Yep.
Cheers. Don't make me stand here all in silence. It's very awkward. I'm going to make a copper polyester taffeta corset because I want one. I don't know what it'll do yet. And I'm going to put flex resistors into bicycle pants so they'll light up and cars will, to an extent, know what speed you're going. Okay.
Yeah, it was about the bicycle clothing I liked. I think you should develop that more. And it's really useful. In a place like Berlin, people like to get on a bicycle just wearing street clothes, just wearing the clothes that they're going out in and so on. Other places they put on a plastic suit and get right down into it. But in places where people cycle in their ordinary clothes, having sensors built in to your ordinary clothes is a really good idea. And what I'd like to see is at night that you could have something that's sensitive to the lights of cars, so that you've got something on the back of your clothes. You go somewhere, you don't see anything in particular other than the nice clothes, But then when you're on your bike, some lighting comes from behind. As the light gets closer, the intensity of your LEDs becomes stronger, and then the bicycle is much safer. I
That'd be
think it's a
very
really good
cool.
idea.
I could
And
do that.
I can't imagine making it myself, but I'd love to buy such a thing.
I'd actually started talking with my friend Dan Kroll from Chicago about that. He wants to do the same thing. He's a huge part of the cycling community, but he wants to make a helmet that'll do it. But I think street clothes is a better idea, I agree. That's how everyone bike rides in Chicago. Hi.
Hi. I'm actually pretty curious to know your secrets about washing all this.
As of yet, I have not had to, but I'm going to say very carefully. And I wouldn't put it through the machine if I were you. Yeah, we'll do that. That sounds good. Anything else?
Anyone else have any other questions, comments, questions, ideas?
Woo! Yay! Any of these, you're welcome to talk to me, and you're welcome to. The Fabric Light Bright's a lot of fun. Cheers.